Here we have an equation for an ellipse. An ellipse is an elongated circle. The planets have an elliptical motion, not a circular motion. And it's just exaggerated. So that's A, and that's negative A, and this is B and negative B. So for example, if we have x squared over 16 plus y squared over 9 equals 1, then that would look like x and y. Then there's our ellipse. So this would be 4, this would need negative 4, this would be 3, negative 3, and this would be 3. Of course, that could be rewritten as 9x squared plus 16y squared equals 144. If we take any point on the circle, so that's x, y, they also can be written with parametric coordinates. So that's going to be A cos theta, B sine theta. Okay, let's have a look at some transformations. So this is an ellipse, the general formula. And at the moment, you can see those values of m, n are 0, and a is 1, and b is 1. So actually, this is a circle. Okay, so let's turn it into an ellipse. Let's make a 4. Okay, and let's make b3. So as A and B change, that's what happens. And let's move this ellipse to the right. So we're going to change the x value, and so we're going to subtract, let's say 1 there to make it like that. And let's say we want to move it to the left, so we're subtracting that positive value there, just like any old transformation. Let's put it there, and then let's move it up and down the y-axis. So that's inside the bracket, and we're going to move it up and down like that. Okay, and so we have this examination question here. It says the curve C1 has equation x squared over 16 plus y squared over 4 is equal to 1, so that's the ellipse. And it says this is reflected in the line y is equal to x. Write down the new equation. So C2, the new curve, we literally just swap the x and y's because that's what reflection in the y-axis is. Part B, curve C3 is a circle of radius 4 centered at the origin. How can we go from C1 to C3? Okay, so it has a radius of 4, so let's keep the x squared over 16. So we need this to be y squared over 16 is equal to 1. So the y needs to be replaced with y over 2. And or there must be a stretch parallel to the y-axis, scale factor 2. Okay, part C. C4 is a translation of C1, so don't forget C1 is x squared over 16 plus y squared over 9 is equal to 1. So C4 is a translation. It says the positive x-axis and the positive y-axis are tangents to C4. Okay, so I'm actually going to draw this. Here's C1. There's C1. And it says the positive x-axis is going to be a tangent and the positive y-axis is going to be a tangent. Pardon the drawing, but it's going to, it goes through there, doesn't it? Looks something like that. And we've got to figure out, these two coordinates here. So that's going to be 4, 0, and that's going to be 0, 2. And we've got to give the translation vector. So the translation vector, if we look at the center of the ellipse, that has coordinates 4, 2. So the translation vector is 4, 2. Then I'm going to use that diagram for the next part. Oh yes, that's the determined translation vector 4, 2. Now it says the line y equals mx plus c is a tangent to both c1 and c4. Find the value of m. And then notice it's only 2 marks, so this is the calculus question. Just go back to this diagram here. Then it's going to be that tangent there, so that's going to be y is equal to mx plus c. And can you see it must be parallel to the translation vector? So the translation vector was 4 across and 2 up, so the gradient of that, and hence the gradient of the tangent, is 2 over 4, which is a half.